Multiplying and dividing rational functions. Okay, first of all, we're going to start with reminding ourselves how to multiply and divide fractions, because that's what rational functions are. Rational just means fractions. So, for the first problem, we're going to multiply these two fractions. Anytime we're multiplying, we just multiply straight across. If possible, we can cross simplify. So if 1 and 6 had a common factor that we could cancel out, we could do that. Or if 3 and 5 had a common factor, we could cancel something out there. But that's not the case in this problem. So we're just going to multiply straight across. 1 times 5 is 5, 3 times 6 is 18, and this can't be simplified any further. When dividing, we use KFC. Keep, flip, change. We're going to keep the first fraction, we're going to flip the next fraction, and we're going to change to multiply. Now notice we can cross simplify here because 3 and 6 have a common factor of 3. So what I'm going to do is I'm going to cross off and divide both of these by 3. So I get 1 and I get 2. So now, checking the other way, no common factor, I can just multiply across. 1 times 2 on the top, I just get 2. And on the bottom, 1 times 5 is 5. This problem says simplify the expression. So we're going to start by looking at our coefficients, our 3 and our 12. I can simplify those by dividing them both by 3. So that gives me 1 over 4. And then I can go and look at my x's. X squared over x is just x to the first on the top, because remember we take 2 minus 1, and that gets us 1x left on the top. This is an acceptable answer, or you could just put x over 4, since we don't need the 1. Now something to note here is that x can't be 0. The reason it can't be 0 is because if I put 0 in here for x, I would have a 0 in my denominator, and then I would have an undefined situation, because you can't divide by 0. Okay, same idea, but a little bit more going on here. So let's start with the negative 16 and the 12. I can divide 4 out of both of those. Now we'll look at our x's. X to the 5th and x squared. So I'm going to take 5 minus 2 and I get 3, and it goes on the bottom because there were more x's down here to begin with. Remember, that's the same thing as writing out 2 x's on the top, 5 x's on the bottom, and canceling 2 out of the top, 2 out of the bottom. You're left with 3 x's on the bottom. And then my y's, same idea. I have y to the 7th on the top and y to the 3rd on the bottom. 7 minus 3 is 4, so it's going to be y to the 4th on the top. And z's, there's nothing to simplify those with, so we just have z to the 4th on the bottom. Now again, we have x can't be 0, because we can't have 0 in the denominator. Z can't be 0, but also we have to note that y can't be 0. Even though our final answer didn't have a y in the denominator, it still at some point was in the denominator of the problem, so we need to make sure we note that it can't be 0. This problem looks different than the last problem because I have subtraction going on. Subtraction or addition, it wouldn't matter which one. So what we're going to have to do is we're going to have to factor the top and factor the bottom. So whenever you have binomials, you're either looking for a greatest common factor and or a difference of squares. So on the top here, I definitely don't have a difference of squares. Remember, difference of squares would look like 4x squared minus 9 or something, where 4 and 9 are perfect squares, and you have a subtraction sign, and you only have an x right here. So with the top, 3x minus 12, I'm going to pull out a greatest common factor, which would be 3. If I divide 3x by 3, I get x. Negative 12 divided by 3 is negative 4. On the bottom, same thing, but now my greatest common factor is 3x. If I divide 3x squared by 3x, I just have x. And then negative 12x divided by 3x is negative 4. Okay, so now we can look for things that are similar on the top and the bottom and cancel them out. First of all, I notice that I have a 3 being multiplied out front on both of these, so those can cancel out. I also have a common factor of x minus 4. Now I have to think about this factor as one thing, so it all gets canceled out. And all I have left is this little x right here. So my final answer is 1 over x. Okay, so now we need to think about what x can't be, because there's some restricted values here. X can't be 4, because if x were 4, this expression right here would have been 0. 4 minus 4 is 0. X also can't be 0, because if x were 0, the expression 3x, 3 times something, would also be 0. So x can't be 0 or 4. Okay, so again we're going to have to factor the top and the bottom on this problem because I see plus and minus going on in both the top and the bottom. So factoring here this is going to be easy factoring because we don't have a number out in front of our x squareds. So we're going to say what multiplies to 6 and adds to negative 5. That would be negative 2 and negative 3. They multiply to positive 6 and they add to negative 5. On the bottom, we're going to say what multiplies to negative 15 and adds to 2. That would be positive 5 and negative 3. Okay, now we can look for common factors. Again, we have to think about these as a whole factor here. I can't just cancel out the 3's. I would have to cancel out the entire x minus 3, which is what we can do here because I have an x minus 3 on the top and the bottom. So my final answer here is x minus 2 over x minus 5. You cannot cancel these x's out. That is a common mistake people make. You cannot cancel those x's out when they're attached by addition or subtraction to something else. So since we have x minus 2 and x minus 5, you can't cancel out the x's. Now we need to see what values x can't be. So look at our factored form here. We're only looking at the denominator, at the bottom of the fraction. The numerator doesn't matter because we can have 0 in the numerator, We just can't have 0 in the denominator. So here, x can't be negative 5 or positive 3. If x were negative 5, this term would be 0. And if x were 3, this term would be 0. Even though we're canceling out that x minus 3, we have to account for it. Okay, so now we don't have any adding and subtracting going on, so we can cross-simplify if possible, which I believe we'll be able to do on this one. So let's look at the 96 and the 45. Okay, 96 and 45, I think they have a common factor of 3. So if I divide them both by 3, let's see, we get 32. 96 divided by 3 is 32. And 45 divided by 3 is 15. I'm sorry, I put 3, but I meant to say 15. Okay, so that's all the common factors across that way. Across this other way, we don't have any common factors. 25 and 38, there's nothing in common, and there's only one in. So now I can look again on the top and bottom if I want to, and I could simplify these fractions again. So looking at 25 and 15, actually, yeah, why don't I rewrite this? That might be easier. Okay, so now I can do this again, and I see 25 and 15. I can divide both of those by 5, so I get 5 over 3. 32 and 38, I can divide both of those by 2. So then we have 16 over 19. Let's see what we have now. We have 16 over 19n, don't forget about that n, times 5 over 3. Okay, I think we've simplified everything we can, so let's just go ahead and multiply across. So we have 80 over 57n. Now the point of doing all this simplifying as I go is the idea would be that it'd be a simplified form at this point, and there is nothing that divides 57 and 80. So I have my final answer here, and make sure that you note n can't be 0. Because if n were 0, my denominator would be 0. Okay, now we're going to multiply two rational functions. Before you multiply, you have to make sure that everything has been factored. So my x plus 7 and my x minus 8, those are already factored. There's nothing else to do there. But the 7x plus 35 and the x squared minus 3x minus 40 still needs to be factored. So I'm going to leave x plus 7 the same. 7x plus 35, I can pull a greatest common factor of 7 out. Leave it as multiply. X minus 8 on the bottom is good. Now on the top right, I should be looking for either a factor of x plus 7, x plus 5, or x minus 8. That might help me factor this, knowing that I should be using one of those numbers most likely. So I want to see what multiplies to negative 40 and adds to negative 3. That would be a negative 8 and positive 5. And now I can simplify anything on the top with anything on the bottom. So I have x minus 8 and x minus 8 that I can cancel out. I have an x plus 5 and an x plus 5. I cannot cross out these 7s. Do you see how one 7 is x plus 7 and the other 7 is just being multiplied out front? So I have to leave the 7s. So there's my final answer. And then we need to look for our excluded values of x, so what x can't be. Right here, x can't be negative 5, and right here, x can't be a positive 8. Again, the numerator doesn't matter. It's all about making the denominator not equal to 0. Make sure that you check your final answer as well for anything in the bottom that x can't be, but since it's just a 7 without an x, we're good to go. Okay, when dividing, we're going to need to use KFC, keep, flip, change. So we're going to keep the first fraction the same, n plus 5 over 10. Flip the second fraction, and change to multiply. Okay, looking at these, I only have one part of this that I can factor. The only factorable part is 3n plus 18. And I can pull out a greatest common factor of 3. Now remember, we cannot simplify this 5 and the 10 because the 5 is attached to the n by addition or subtraction. What we can cancel out though is this n plus 6. So then what I have left is 3 n plus 5 over 10. This 3 came from right here. Don't forget about what's out front there. Now I can check if I can simplify my 3 and 10. I could do that because they're both just a number without being attached to an n by a plus or minus sign. But I can't simplify 3 and 10. Nothing divides both of them. Now I need to look back through the whole problem and find anywhere where my denominator had an n and see what would make it 0. Well, up here at n plus 6, I could have had, if n was negative 6, it'd be 0. So that's what n can't be. I put in the x. Okay, we're going to divide again, so we're going to keep flip change. We're going to keep the first fraction, but I'm going to go ahead and factor it while I rewrite it. So the top one multiplies to 54 and adds to negative 15. That would be x minus 6 and x minus 9 over multiplies to 48 and adds to negative 14. I believe that'd be 6 and 8. So let's see, x minus 6 and x minus 8. Flip the next one, so I have x minus 8 over 1 now, and change to multiply. Okay, common factors that we can cancel out. We have x minus 6, and then we have x minus 8, x minus 8. We're just left with x minus 9 over 1, but I'm not going to write over 1 because we don't need to do that. And looking back through the whole problem, it looks like x cannot equal positive 6 or positive 8. That would make my denominator 0. Okay, I want you to pause your video right now and work these two problems out and then restart the video to see my answers. Okay, in the first one we did have a difference of squares show up. So right here where we had a squared minus 16. The way you factor that is you take the square root of a squared, you get a, and you take the square root of 16, you get 4 and 4, one with a plus sign, one with a minus sign. So you're probably going to see difference of squares a lot in this concept, so make sure that you remember to factor those that way.